brighter it's going to be. And then if you push it too far, it's going to get hot, it's going to smoke, it's going to be gone. So some of the tests that you do if you don't have a meter, if you smell something, it ain't very good. If you see smoke, it ain't very good. So you better turn that switch off. Don't let it go. Yeah, do you have a question?
Yesterday morning I woke up and I kept, seemed as if I was smelling the electricity.
Yeah.
And I looked around my computer and all that stuff, I didn't see anything. But it just, you know, I know the smell of electricity and I could smell it, but I didn't understand that.
Turn it off.
Just turn it off anyway?
That means there's something wrong somewhere. Yeah.
Okay.
Yeah, if you smell it or see smoke.
I didn't see any smoke, I just woke up and I could smell the electricity.
Yeah.
Kind of stuff.
You left the coffee pot on, it was empty.
No, it turns off by itself. I thought it was something with the computer, so I bought one of the old ones back.
Okay, let's get to the meter. This meter I got about a year ago at Radio Shack. So you can buy them. You said Lowe's.
Just about anywhere, Harbor Freight.
And there's different kind of meters. More than likely you're going to buy one kind today, but you do have options. You have the old analog meter. You know, analog's going to go like this, right?
Okay.
Okay. The digital meter is going to give you a digital readout. Okay. And then, I guess depending on the price you pay, and so on, there are some. We've talked about range here. Okay. 1 minute we may be down here measuring 1 volt. The next minute we're down here measuring nanometers. Okay. So with the floating decimal point, like in computer math we talked about, frequently you have to set a range here. But you've got to know if you're dealing in nanometers or you're going to deal in volts. Like this is 110 volts. So on the decimal point, 110, we're up here, 10, 100. 3 places here from 0. Here we may be 6 places down for milliamp. So anyway, the other thing in electronics is you always have at least 2. For current to flow, you're going to have a positive and a minus, okay? Positive is almost always red. Minus is always black, okay? Or you can call this a ground. It's better to have 3 of them, like on our modern day plugs. The old plugs only have 2. The low powered ones only have 2. When you get to high power or modern day, like electricity in the house, you're going to have a separate ground. This can act as ground too. So your meters usually show you where to plug it in. Plug the red into red, there, or here. Okay? They're colorful. So now, to some extent, you have to know a little bit about the device you're using. You want to plug positive into positive, negative into negative. Okay? It really doesn't matter a whole lot because to some extent it'll just come up with a negative figure rather than a positive figure. So most of them turn off, then you turn it on. And here I have volts, then I have, I'll pass this around. Then you have the milliamps and the microamps, so then you have your ohms there. So you set it to where you want. I'll pass this around while I talk. Just look at it going around. So the thing you're going to test, most likely, is going to be the volts, okay, the resistance, amps, and ohms. However, in your case, the most common thing you want to test is what they call continuity. In other words, if that thing is shorting out, it probably burned a fuse. Jack talked about burning a fuse. That's what we have fuses for. If you overload the circuit, this thing is gonna blow, and so you won't burn your house down. Okay? Years ago, I still remember my dad going down in the basement and putting a penny in there. And the fuse blew. We don't have electricity, so they were gussing it through, but anyway, that was the old way of doing it. So now the penny does not really act as a fuse, it acts as a conductor. So now, if that thing is shorted out, wherever it is, it's gonna start heating, it's gonna burn, it'll burn that wall.
I was gonna say it will burn.
But we don't have so many
So
fuses
if it, that's
anymore.
what I'm saying,
We
if
have
it
so
smokes,
many.
or you smell it, turn it off, don't guss it through. Do you
I
have a
was
question?
saying, you know, I'm old enough, I know about the
Fuse, the old fuse stuff.
but we mostly have, circuit breakers now, right?
Right, now we have, circuit
They'll-
breakers
they'll-
running fuse,
they'll pop
all
off.
that means is you don't have to go buy another fuse, you put it
Okay.
in, just flip the switch. The circuit breaker will go out,
Uh-huh.
you broke the circuit, okay, and then you flick it back. So, at my house, it happens frequently with the microwave. You got the microwave and too many things going, it's gonna break the circuit. So, you through with that?
They have a new type. Yeah. It's called arcs.
Well, is that too much of a demand? I mean, the flow is insufficient?
The what?
Like when you've got a whole bunch of things turned on and the circuit breaker trips, is that because there's insufficient flow?
Well, just what we're talking, yeah.
My house is
You're-
wired with them.
Like what we talked about here, let's go back to this. This is one, okay?
Yeah,
Like that, pretty close. Anyway, this is, let's say, 1 volt. It's all it takes to light this, okay? However, the range is plus or minus, which it won't be that much, but that's 2 to 3. So the bottom line is, anything in that circuit, bulbs or whatever, if you push too much through without a resistor, you're gonna burn it.
okay,
So that's true of anything.
okay.
The most common is lightning. If lightning comes and hits your house, what happens to your
You
computer?
blow a lot of things all over the place.
Everything's gonna pop. It's gonna send what, 10,000 volts through that
Yeah,
system in a
yeah,
split
yeah.
second? Now, if you don't have this is something Roy should talk about computer class, you should have what do they call
Surge
it?
protector.
Surge
Whole
protector.
house.
A surge protector, yeah. And that really is a fuse, is all it is, yeah.
Can't you get a larger breaker for your box and
Say again?
a larger breaker for your breaker box so that you're not blowing it or flipping it?
But you don't really want that.
You gotta switch.
Yeah, in
That's
fact, you will
dangerous.
have, a lot of people don't know, but we're talking electricity, and maybe we need another class, that, 210 comes into your house, okay? You use it for
220.
Your washer, your dryer. You don't want 210 going through these wires. So you're gonna have a different kind of plug, you're gonna have the heavier wire, okay? So, and the bottom line is, they split that off into 110 when it comes to your house. So 110 goes around the house. So you don't want to put the big fuse box circuit breaker. In fact, if you look at your boxes, you're going to have some of the big circuit breakers and some of the little ones. I've got like 4, I think 4 and then 16 or 20 little ones here. But you don't want that one because again, it's not going to break the circuit until something's on fire.
Thank you.
In a lot of medical equipment, you use 240 volts too. X-ray machines, ultrasounds, a lot of that stuff. Okay. Oh, motors. We've got some motors here today too that we're going to test. There's different kind of motors. In addition to being big and small, we're talking about small now. You have motors that are the regular motor, DC motors that turn like this here. Okay? Then you have motors like on your car, windshield wiper, that just go like so. Okay? These are are all done with electricity, various ways of manipulating and massaging electricity. Then you have what they call stepper motors that go 1, 2, 3, 4, 5, 6. And it gets very complicated related to the way the computer handles electricity that goes there. And then batteries are the next thing. Most of these you probably will know. Anybody know what kind of battery is that?
I'd say it's a dry cell.
No?
No?
Rechargeable?
Lead acid. So
Well, it's not a dry cell.
these are dry cells.
Yeah, yeah.
This is lead acid. Okay, so lead acid batteries obviously very, very dangerous. You can't throw them in the garbage. You have to dispose of them in a certain way, and so on. And you should always wear goggles. I just had an argument with the team about that. Jumpering a car, don't jumper a car if you don't have glasses on, or preferably have goggles on. That's acid, gets on your face and your eyes. If your eyes is gone, gets on your face, that's acid burn. So that's lead, that's dry cell, at least in my opinion, these are dry cell type, okay? So this is a, maybe I didn't bring it, I thought I did. Anyway, the smallest one like this is AA, okay? How many volts? 1.5. Usually it'll tell on. I think. Anyway, AA, the bigger ones. And then the square one, how many volts? You'll know in a minute when you measure them. 9 volts, right? And then the new type, which are a major problem in life to us, is a light bulb battery. This is what they're using in all the drones and anything like that. Okay, these are the ones that blow up frequently. And that's why you buy bags like this here. You charge these kind of batteries in a bag. Okay? And you carry them, if you do right, you carry them out wherever you're going to go, especially in the summer. Not in the drone, but in a bag. Put it in the drone or put it in your device out there. Don't carry them in a regular bag where the bag's sat in the car at 130 degrees, you're going to have problems. So LIP, capital L-I, capital P-O, lipopolymer battery. And that's what they're coming, this is what, they're getting smaller, that's how they got smaller, and so on, so. Okay, and here's a motor. This is called a geared motor because it doesn't come off from the center, there's a gear in there that turns it. So anyway, gear motor, 12 volt DC. Now that's the other thing. I don't know a whole lot about AC, but I'm not an electrician, so I don't use it. I don't fix my own radios. I don't fix my own TV. But in the world of electronics now and in medicine, as I said, we're way down here. So there, everything is safe. That's why most things you buy now in the house, even if they're 110 volt, you're going to have a transformer or something to change it down to a very low voltage. So they're basically relatively safe. 110 volts is not safe. You don't want to get a little nick in a 110 volt wire and start handling it, especially if you're standing on water. There was a minister in Waco about 10 years ago that got executed by it. You remember that?
Yes.
He had a microphone. He was baptizing people the way they don't know. And so on, he executed himself. Anyway, Jack, let's start with you. Jack's the one that asked for this class. Plug it in.
Which one of the reds am I going toward?
Okay, now, yeah, let me go with that. Let me get the battery out here. This is a common one here. This one here, you'll see unfused, okay, and that's for 10 amp max, so
Okay.
we aren't gonna use that today at all.
Okay.
So here it says volts, so you're gonna measure volts. Yep. Turn it on.
I don't even know how to turn it on.
Okay, here's your switch, turn it on.
Okay.
There's volts, here's milliamps, here's your ohms, and then continuity and various things, so all of them work with today.
So we want to come down one more, don't we?
Yeah, you'll come down to volts.
Okay.
My mother and stepdad's house are running down extension cords.
Oh, really?
Yes, ma'am.
What's the rate?
I was going.
1607.
I was
It's an
saying,
old building,
Let's get a,
my husband
one of these.
1607 is
was
one L.
and we was trying to do.
I don't know. Is there
This
a
motion line.
one decimal
We had
point in
to play
there?
it, And he couldn't his arm stretch out, so he was telling me what to do, and I was scared.
Okay, so I